start our class. Yeah, it is recording. So how many of you go through these problems?
আমি করেছি সব, মানে চেষ্টা করেছি।
Hello, how many of you go through all the few problems at least? Hello, please respond. It is supposed to be an interactive session, and if you don't respond,
Sir, can you repeat? Actually,
okay, I am asking how many of you actually tried the problems.
सर एक्चुअली मैंने वो थ्योरी ही देखा था, सर ने जो पढ़ाया था, मतलब वो बुक्स वगैरह कुछ मतलब रेफरेंस नहीं दिए थे ना, तो मुझे
Uh,
ऐसा कुछ मतलब ट्राई नहीं
no,
किया।
actually, just a minute. He already he already mentioned that everyone should go through all the problems of Fatia McDonald chapter 1. The There is a message in the group.
হ্যাঁ করেছি, কন্টিনিউ করো।
তোমাকে বলিনি, বাকি
সব
লোকজনও তো রয়েছে। So okay, so what should I do right now? Go through all the problems or give you some more time to see, then we solve the problem? Just a minute. Okay, so okay, so I am discussing the solution. So please at least respond or interact in the class. I mean, some of the problems are very easy, so we can actually solve them in the class. We don't need to solve it in the home. So that, I mean, don't tie the stick the next day. Actually, the problems become harder. Okay, so let's copy and paste. Huh. So anyone, how to solve this? First of all, am I audible? I mean, hello, hello,
यस।
hello. Okay. So please tell me how to solve this. Any idea? Any idea how to solve this problem?
এই তো এটাকে তোর ওই ইয়ে 1 মাইনাস এক্স প্লাস এক্স স্কোয়ার, আবার তারপরে প্লাস মানে প্লাস মাইনাস করে কম্বিনেশন করে, মানে এক্স এর তো মানে একটা নীলপটেন্ট এলিমেন্ট, তো এক্স টু দি পাওয়ার সাম কে ইকুয়ালস টু 0, তো মানে তার আগের পাওয়ার অবধি মানে প্লাস মাইনাস এর কম্বিনেশন করে, মানে এক্স এর পাওয়ারের ওটাতে কম্বিনেশন করে লিখলেই ওটা মাল্টিপ্লাই করলে ওটা ইউনিট দিয়ে হবে।
Okay. So
আই গেস তুমি যদি এক্সটাকে ফার্স্টে মাইনাস ইউ ধরে নাও তাহলে বেশি সুবিধা হবে।
okay.
সেটাও করা যেতে পারে।
So what Javed is suggesting that since x is nilpotent, there is some n greater equal to, yeah, is n greater equal to 0 such that x power n equal to 0. So we may look at that element 1 minus x plus x square up to minus 1 whole power n minus 1 x power n minus 1, and this is the candidate for inverse of 1 plus x. So since x is nilpotent, okay, there is some n belongs to natural number Okay, for me, okay, natural number union 0, let's write such that x power n equal to 0. Let's look at the element. One minus x plus x square plus plus minus 1 whole power n minus 1 x power n minus 1. Note that 1 plus x, if you multiply it from, anyway it is commutative ring, so we did not need to bother anything. Xn minus 1, this is just 1 minus x power n, which is 1. So so we have found element such that the multiplied by this element gives 1, therefore 1 plus x is unit. And for the next part, let u belongs to a cross. Okay, so for a commutative ring, a set of all units of a will be denoted by a cross, and x belongs to nil radical. Nil radical is denoted by, usually denoted by root 0. So we need to show that u plus x is an unit. Okay, so u plus x, so taking take u out, so it is u of u inverse x. Yes, now you have this. Okay, observe. Since root 0, okay, root 0 is an ideal, right? Since root 0 is an ideal of a, u inverse into x belongs to root 0, as x is in root 0. So by the first part of the problem, the same problem, 1 plus u inverse x is unit, and if you multiply 2 unit, it becomes a unit. That implies u into 1 plus u inverse x is unit. That implies u plus x is unit, and we are done. And this is an easy problem actually. Okay, so problem 2. Anyone? Hello?
তুই ওটাকে এখানে দে, এখনো মানে আমি মানে আমার নিজেরও দেখা হয়নি, ঠিক আছে, বাট মানে তুই দে প্রবলেমটা, দেখা যাক
না
কি
না,
কি
সে আমি দিচ্ছি, কেউ যারা, ওকে, সো I understand that you may, oh shit, okay, I understand that you may have some really serious work, that's why you cannot solve the problems. Okay, what the hell.
এই ওটা তো দুইয়ের ওয়ানেরটা তো একের থেকেই হয়ে যাচ্ছে, তাই না? দুইয়ের ওয়ানেরটা, পার্ট ওয়ানেরটা একের থেকেই
we have done that, yes, exactly, we have done that. Okay, so I am posting the second problem right now. I understand that some of you have really important work in your life, so you can solve the problems. That's okay, that's fine. We may discuss them in the class, and then let's try to solve these problems. So please, anyone, any idea how to solve this? The first one, Atiya, I think Atiya have some hint. If B0 are inverse of S, prove that. Oh, Atiya says use induction, and then you use the previous exercise to conclude the result. Okay, Atiya gave some hint. Um, if you want to use that hint, you may use that hint. If you have any different solution, please say that, or try to think for a few minutes. Then we will discuss the solution.
Sir, a1x plus a2x
Okay,
square
okay, you have done that, right?
হ্যাঁ
So
Sir,
okay, so
ওটা তো
just
নিউটন
a
এলিমেন্ট
minute,
হবে
just a minute. So since you have done that, we will listen your solution. Just give some time to other people. Okay, what are you? Someone
sir,
saying
like,
something. Okay, someone saying
yes,
something.
sir.
Yes, please.
So, sir, here f is unit, so we get that exists a g of x like in ax, such that f of x into g of x equal to 1.
Hmm.
Then by comparing 0 degree element, we
Yes.
get a naught into b naught equal to 1. That
Yes.
implies that a naught is unit.
Yes.
Then we define a mapping rx to r by p of x,
Okay.
and then like here f of x is unit, so pi, like my math is pi, so pi of f of x also unit in r by r mod p of x.
Hmm.
Then in that a naught, my pi of f of x will be a naught plus p plus a1 plus p of x
Hmm.
up to an plus p x where n is unit.
Hmm.
Here r mod p of x is an integral term. So units of r mod p of x implies units of r mod p. So uh, so all ai's are belongs to p, where I is greater than equal to 1 and less than equal to n. So uh, here, and p is prime, arbitrary prime, so it belongs to intersection of p. So they are nilpotent.
Okay, so
A1 up to an are nilpotent.
okay, so you have seen that solution. Okay, my solution is exactly the same solution. So before proving that, we need to prove some fact that units of integral domain is same with units of x. If A is an integral domain, X is an integral domain. So all of you understand the solution that Madhav said? We need some facts
Yes.
or some proof. What about Divya? Are you there, Divya? May not be. Okay. She might be busy in some.
Yes. No, no, sir.
Okay, so did you understand the proof that Madhav said?
Yes, sir.
Sorry?
Yes, sir.
I did not understand whatever you were saying. Please. Okay, so we need some fact to, and one thing we can do that. Okay, so some facts that is left as an exercise to check. One. This is a digression. I mean these facts will be needed to prove that problem. Okay, so facts are the following. Okay, let's remove this. Facts are the following. If A is an integral domain, integral domain, then AX is integral domain, to same as okay, so A cross is set of all units of A. So we will be using these two facts to prove one. So okay, to the next page. 3 1 since f is unit, there is gx. Let's say gx is of the form b0 plus 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 bmxm belongs to a round square bracket x such that fg equal to 1. Okay, bm not equal to 0, b0 to bm belongs to a. Huh? Such that what is fg equal to 1. So f is a0 plus 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 amxm and it is b0 plus 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 bmxm equal to 1. If we multiply them, a0 b0 plus plus plus, I don't care about other
Why you have considered the utmost degree of V is M? Means G is M.
I'm sorry, what is your
Why both polynomial have the same degree?
okay, no, that is typo. It's a and bm. What is, I mean, f has degree n or m? F has degree n. That is a typo, nothing else. Thanks. So if we compare the coefficient from both sides, we see that a0 b0 is 1. This gives a0 is unit. But what about the other coefficients? So let p belong to spec a and look at the map, natural projection map pi ax, reducing the coefficient modulo p. If we have a0 plus 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 a n xn, we are sending it to a0 plus p plus 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 a n plus p xn. So okay, since f is an unit, f belong to a star, this implies pi f is in also s. Pi f belongs to a mod p a star, but a mod p is domain, imply a mod p x is also domain. This imply pi f belongs to a mod p by the fact 2. So that implies that ai plus p equal to 0 plus p, I1 belongs to this range. This means ai belongs to p. Now p belong to spec a is arbitrary. This implies ai belongs to intersection p belongs to spec ak, that is root 0. 1 lesser equal to I lesser equal to n. That implies i's are nilpotent. Okay, so this gives the first part, this side. What about the other side? Okay, so we have shown that if f is an unit, then a0 is unit and a1 up to n are nilpotent. What about the converse part? What about the converse part?
Sir, if a1 up to an are nilpotent, then a1x, a2x square, and anx square n also nilpotent, and that summation also belongs to summation also nilpotent, and a naught is unit. So by question number one, we can say that
Yes,
a
actually.
naught.
And one request to Madhav, that don't call me sir, you can call me by my name. I am not sad.
Sorry.
Okay, and okay, so Pinky Di, what is your solution? Please tell us.
হ্যাঁ ওটাই।
Same solution. Okay, so this part,
ওটাই
yes.
ওটাই এটা বলি, এটা আগের পার্ট থেকেই ফলো করবি,
Follows.
মানে কোশ্চেন নাম্বার 1।
Yes, this part follows from exercise 1. That is easier case. Okay, what about 2? What about 2? Divya? Oyon? Oyon, are you there?
Yes, I am here. I was thinking about the same trick, taking the projection,
Yes,
taking
yes.
a prime ideal.
That will work. That will work. If you guys are watching test match, please update me the score after few overs. Whatever. Since you have not present in the class, you may watch the test match. Same proof. So same proof means if f is an nilpotent, the image is also nilpotent, and reduce it to the R mod P. R mod P is domain, so there is no nilpotent element. So all the coefficients, all the coefficients are 0. So ai's are in P for all I, so they are nilpotent, and the converse is follows, since root 0 is an ideal, so those are in the root 0. Okay, what about the third problem? What about the third problem? Is it visible? I mean, this is too small for you guys. Okay, let me increase the size.
It will be great if you increase the size, please.
Now it is okay, right? Okay, so what about, okay, we have done these two. What about the third problem? That if it is zero divisor, you can only they are of this form, that A is in A. Oyon, Pinky D, Madhav.
just take the product of the each coefficients zero divisor or whatever you would say. Suppose a naught has some b naught such that a naught into b naught equal to 0. So take b naught
Just a
b1
minute.
dot dot bn
No,
as b.
if has the if is a0 plus a1 x dot dot a n x n. So if is a zero divisor means there is an g such that gf equal to 0. You need to show that such g is in a. Okay, so how you are going to show that? You are Oyon, what is your solution? You are taking something.
Just wait a minute. I guess I did something wrong. Just wait a minute.
No, that's fine. If anyone has any other solution, feel free to discuss here. Pinky ji,
I was just telling that if f is a zero divisor, then each term would be zero divisor. Okay,
okay.
and then just take if a naught into b naught equal to 0, a1 into b1 equal to 0, dot dot a and bn equal to 0. Just take a as b naught b1 bn.
Yeah, but it is not true, right? It is not true.
Just let me think. Just let me think. Pardon.
You mean you are saying that if f is a zero divisor, each uh, coefficient is a zero divisor.
Yes.
So each coefficient is a converse is true, that each coefficient is zero divisor, then f is a zero divisor. That's fine.
I think the converse is obvious, but
Yes. So if each coefficient is a zero divisor, then f is a zero divisor. So I pose a comparatively easy question, that suppose A is a ring and say that D is a collection of all zero divisor in that ring. Is D is a subring of A or ideal, or D has any substructure, or D is a group, D is indeed not a ring because one is not in that D. For us to some set is to be a subring, is one should be in that subset. So D is not ring, but
I guess I can prove it by induction. Whatever I just said.
which one that
That each coefficient would be the zero divisor, because by induction you can take induction on the degree of the polynomial.
each coefficient is a zero divisor. Induction in the number of the coefficient.
No, on the degree of the polynomial.
Okay. So we have comparatively much easier proof, it seems. So please prove that, Ayon, and post it in the group. We will review that proof surely. So should we wait for you?
No, just carry on. By the way, can you repeat your solution? I just missed it.
What? I mean, I am saying that you have said, you said that you want to show if f is a zero divisor, each component.
No. I was thinking. Okay.
No,
What
whatever
I
you are thinking, or whatever is your assumption or intuition, that if f is a zero divisor, each coefficient is a zero divisor, and the vice versa. So I am asking that suppose in a ring A, let D be the set of all zero divisor. Is D a group or ideal? I am collecting all the zero divisors, and then I am interested to see that if D has any substructure like subring, subgroup, ideal, blah blah blah. So is D has really any kind of substructure? Is D closed under addition, multiplication, whatever? Can you prove that such a thing for a collection of all zero divisors of a ring? That's my question actually. Okay, so we need to prove the third problem.
So it can't be group actually.
Okay, so it can't be
Just take Z6 and take items 2 and 3.
Yeah,
It should
2
work.
and 3.
exactly.
And it can't be also ideal.
No, it is not. See, it is not closed under addition. How it can be? Whatever. Yes,
আমার
yes.
মনে হয় শুধু সাবরিং মানে অনলি সাবরিং ক্যান
Only
সাবরিং হতে পারে।
addition. It is not closed under addition. In general,
ও
it is not
রাইট
closed
রাইট
under
রাইট
addition.
কোড নট ক্লোজ আন্ডার এডিশন রাইট।
So, and if it is a subring for with respect to our convention, one is in sub, one is in there.
ইয়েস ইয়েস ইয়েস।
So how it can be a subring actually?
সাবরিংও হবে না, না সাবরিংও হবে না,
Whatever.
আইডিয়াল তো হবেই না।
Whatever. So let us prove the third problem. Okay, I am not proving this since the proof is same. So I am not proving this. Third problem. Suppose okay, so we will prove something more general. The result due to McCoy. Okay, I am proving this after I am proving in the next problem. Okay, anyone with the fourth problem?
Sir, what did you write due to?
Due to McCoy has some more general theorem on how zero divisor of an ideal looks like. So we will directly prove that theorem, and for a particular case, we will prove that if the zero divisor, if there exists a non-zero A, such that A f is equal to 0.
So we will take a separate class on that
No.
topic.
Today. I will prove it today.
Okay.
I will prove it today. If you see the next problem, Athiya says generalize the result for the several variable polynomial ring. So it is better to actually in several variable, then it is fine. So how many of you tried the number 4? Actually, I am not able to show that number 4. So your solution is most welcome solution for this class actually. For if no one has come up with any solution with number 4, I will give a solution of number 4 when I am ready with the solution. Unless and otherwise, I had to go to the next problem. Anyone has any solution with number 4?
না পারিনি, নাম্বার 4টা পারিনি একদম।
Madhav, Divya, anyone?
ये जो f and g are primitive है वो fg को primitive implies जो करते हैं वो हम contradiction से prove कर सकते हैं क्या?
Whatever proof.
Think.
I mean, if you have any proof, give me. I am not able to do this proof. I need some more time to finish the proof. If you have
So no sir. No, you don't.
no, okay, so no one has done this. Fine. So sir can't sue me right now. Let's go to the next problem. Generalize the result. Okay, we'll do it later. Okay, let's number 6. number 3. Generalize the result for x2 in several variable indeterminates.
ম্যাকওয়েল রেজাল্ট এই ক্লাসে দেখাবে মানে
Yes, in this class.
আচ্ছা
I mean in this problem actually. In separate section, but in this. Okay, so answer.
Sir, can you kindly make it bigger?
Why are you calling me sir?
Professor, please.
Yes. Call me Messiha. Okay, so Athiya says generalize the result of exercise 2 in the several variable ring. Okay, so the problem is the following. So if f is an unit in k a x1 x2 xn, then we need to show something. So first of all we need to come up with an statement and then prove that statement. Okay, so what is the statement? What should be the appropriate statement for problem 1? Oh, wow. No, fine. I think it is fine. Statement. What should be the appropriate statement for the problem 1 in several variable case? Okay, so mimic the statement. Try to mimic the statement in several variable case, and then we will prove that statement in several variable case. So anyone please give me the statement. Hello. I mean,
Can you please repeat? I got disconnected for a second.
I am saying that okay, Atya says that generalize the result for several variable polynomial ring. So first of all we need to come up with a statement so that we can prove something. So what should be the appropriate statement for 1, 2, 3 and 4, and then we will prove that statement accordingly. So what should be the statement for problem 1 in several variable ring?
Just take a general polynomial. I guess it should work.
What is the statement? If x1 x2 xn is unit in a x1 x2 xn if and only if
ওই ক্ষেত্রে সেমই থাকবে, ওই ক্ষেত্রে মানে তো জাস্ট ওই ফার্স্টের ফল মানে যে জিরো মানে জিরো পাওয়ারের মানে ফার্স্টের যে সিঙ্গেল যে কোএফিসিয়েন্টটা সেটা হলে শুধু চলবে, মানে দ্যাট ইজ এ
We may generalize the statement, but is it even true or not?
sorry, what are you saying?
We may generalize the statement. Okay.
We have to
Just
generalize
take
the
just take if as suppose some summation of b I1 I2 I3 In, and take x1 to the power I1 x2 to the power I2 dot dot xn to the power In. But is it even true?
sorry, what are you trying to say?
আরে ও বলতে চাইছে যে ধর তোর মানে xn এর জন্য কি মানে শুধুমাত্র কোএফিসিয়েন্টটা এ হলেই চলবে সেটা জিজ্ঞেস করছে।
হ্যাঁ
আমার কথা কি শোনা যাচ্ছে?
হ্যাঁ বলো কি
যা স্পষ্ট শোনা যাচ্ছে।
yes what
আর ও বলতে চাইছে যে তো স্টেবল ভ্যারিয়েবলের জন্য কি শুধুমাত্র শুধু মানে কনস্ট্যান্ট টার্মটা হলে ইউনিট হলে কি ওটা চলবে মানে গোটাটা ট্রু সেটা বলতে চাইছে।
that is yes actually yes
মানে ও বলতে চাইছে আমরা তো স্টেটমেন্ট বলতেই পারি বাট দ্যাট ইজ দ্যাট ইভেন ট্রু সেটা বলছে।
okay so
Exactly.
we need to prove that whatever you are saying we need to prove that if you give some statement we need to prove that if we fail to prove the statement then we have to then what we can do that then we need to give some counter example if we stuck at them some proof at some point then we need to find a counter example or we need to find a way to prove the statement. If the statement is false then give a counter example to correct the statement and prove it. If you're so that's how we should proceed. So one statement is the following, that if f is an unit, then constant term is unit and rest of them are nilpotent element. That should be the intuition, and that is correct actually. So let us prove that. So before, so how will we prove that statement? How will we prove that statement? That a0 is constant, a0 is unit and rest of them are nilpotent.
Should we go for induction?
Induction on what?
Induction on the number of variable.
Actually. So I have proved it for 2 and rest of them is follows from induction.
I guess enough to prove for 1. Then just
We
take
have-
that
we have
n
already
plus
proved
1
for
as.
1. We have already proved for
Yes,
two.
yes.
So we need to
I know.
prove for at least 2.
Why do we need for at least 2?
If you are proving,
Okay, you can prove for 2. Okay, just take the ring as A as AX1 and
Yes,
so
yes, 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 yes.
AX1 X2 as AX bracket X1 bracket
Yes.
X2.
That I am talking about the same thing actually. Proving for 2 means a considered axy as ax and the polynomial ring over indeterminate y over the ax. Okay, so I am writing the statement later. First of all, try to prove something. That's pretty weird stuff, but yes, since that is not there, we can do that. Okay, we will induct on R the case R equal to 1 is done. For R equal to 2, write a xy as ax y. Okay, so let if xy belongs to axy equal to a xy is of the form if xy equal to a0 plus dot plus a n yn where ai belongs to ax. Okay, so if f is an unit by exercise 2 exercis to a0 belongs to ax is unit and ai is ai one lesser equal to 1 is nilpotent. By problem 2.1. Okay, write aj is a j comma 0 plus a j comma nj x nj a j comma k belongs to a. For all j and k, I am not writing the ranges. Okay, so a0 belongs to ax is unit implies a 0 comma 0 belongs to a is unit, and a what is the notation, a0 comma k, this k. Okay, no problem. a0 comma k is nilpotent. The k varies from 0 to 1 to k, 1 to k to n0 by exercise EXER exercise 2.1 2.1 and 2.2. Also a I 1 lesser equal to or lesser equal to 1 is nilpotent. Implies all aik I ranges from 1 I, and k varies from 0 k in what is that's a problematic stuff, is it? In I, oh okay, sorry, it is ni. All are nilpotent by EXERCI exercise 2.2. So this implies that a0 is nilpotent and all other coefficients of f are nilpotent. This is unit. Unit and this is what you guys are talking about, right? This should be the conclusion. Hello. What the hell, I am teaching myself. Suppose if x1 dot 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 xr belongs to xr is unit, then right is unit and the rest of the coefficients of f are nilpotent. Yes. So okay, so we have done 2, 8, 2. Same proof. Here comes McCoy's theorem. No. Okay guys, are you still there? So if you are
Yes.
here, please at least respond sometime, otherwise it is not very appropriate. Okay. McCoy's theorem. What is the statement? Let f belongs to a x1 x2 xn suppose there is a G belongs to annihilator of oh no no it be an ideal of ax1 dot 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 axn. Suppose there is some 0 not equal to G belongs to an xn a, then there is some 0 not equal to a belongs to a such that a belongs to an proof. Is the statement clear to everyone? Is the statement clear to everyone? Hello, please respond. Please respond.
Yes.
I cannot see in. Okay.
Yes.
You know now what is. You know.
It's not. Can you explain?
You know what is annihilator. Just a minute. Yes, everything has been recorded. Okay, you know now what is annihilator.
Sir, what are the notations? First you take some mu or something what?
Okay, yeah. That is max bracket. That is max bracket.
Okay, so it's an ideal and then you take
A is
G.
an ideal of A, and if there is some G, we cannot guarantee such a G exists. If such a G exists, then we can conclude something. Okay, so if A is an integral domain and A is an ideal, then obviously such and G not exist, right? So that's why we give some supposition that if there is some G not equal to 0, then we can conclude something, that there is some non-zero A in A such that it is inside the annihilator. And you know what is the annihilator means? Annihilator of an ideal is all such element in that ring such that the product is 0.
Yes.
It forms an ideal. Annihilator of an element or annihilator of an ideal, that forms an ideal in that ring.
Can you just write the definition, please?
Just a minute. Okay, so definition. Where should I write? Okay, I am writing here. Okay. ideal. Define an A to be all such A in A such that A equal to 0, and check that this is an ideal. Okay, so we will prove McCoy's theorem, and you can see that if we can able to show the McCoy's theorem, then our purpose is fulfilled. That means we can prove that exercise 2.3 and the generalized version of that exercises. Can you see that if we can able to show McCoy's theorem, then we can prove those two results. Hello? Hello?
Can you repeat?
I am saying that if we are able to prove McCoy's theorem, then we can prove those two results. That zero, if f is a zero divisor, then there exists a non-zero a such
Yes,
that,
yes.
yes, right. So let's prove this McCoy's theorem, and we will induct on R n basically. We will induct on n the n equal to 1 case. N equal to 1 case. That is, A is an ideal of Ax, and there exists some G not equal to 0 in that annihilator. Then we need to show that A belong, there is some A. Okay. So okay, so should I write this? Let A is be an ideal, and if there is, now suppose there is some G, suppose there is some G not equal to 0 inside the annihilator, suppose there is some G inside the annihilator, then we wish to show that there is some A belongs to, by A star we mean set of all non-zero elements of A. There is some A belongs to A star such that A belongs to annihilator Ax A. Okay. So without loss, we assume that degree G greater equal to 1. If degree G is no, if degree G is 0, then we are done, right? If degree G is 0, then we are done. So we are assuming that degree G is not 0, that is degree G is greater equal to 1. Let G is of the form B0 plus dot 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 of BMXM. BM not equal to 0, B0 to BM are all in A. Since A not equal to 0 for all A belongs to A star. Why is that? If for some A it is 0, then we are done. So we may assume that a is not equal to 0 for all a belongs to a star. B m a is also not 0, also not 0. That is, there is some hx belongs to a such that bm hx not equal to 0. Okay, so write hx to be what, c0 plus 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 cr xr. If bm hx not equal to 0, that implies bm what is bmci not equal to 0, at least for some I, at least for some I, for some I belongs to 0 to r, and that further implies that hx into what is this, gx is 0, not 0. You can see that if bm is non-zero, then if you multiply it by g, then there is at least one non-zero term, unless or until okay, so you can say that hx not equal to 0. So this happens. Then there is some h belongs to a such that a b m h not equal to 0. This blah 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 form. Do we really need this? Do we really need this? Oof. Huh. What is the problem? We cannot say this. There may be some cancellation involved in this computation, and we may have 0 after the product, so we cannot say this. The best we can say this, ci into g is not equal to 0. Ci into g is not equal to 0 for some I belongs to 0 to r. Let j be the maximal with such property. Maximal with cj gx not equal to 0. cj j not equal to 0. J varies on the set. what happens that now G and H equal to 0 as H belongs to just a minute, yes, H belongs to A and G belongs to annihilator. Since G belongs to annihilator, this product is 0. If okay, so this is 0. Now if we product, this becomes 0. Therefore okay, G is of this form, this is of this form. So if we take product, we get that Pm Cj equal to 0. That implies what? That implies Bm G equal to 0. That is a contradiction. Therefore we can say that therefore degree where is it? There is a G. Therefore degree G, what degree G equal to 0. That implies that there exists an A belong to A star such that A belongs to annihilator AX A. Now comes the inductive step. Suppose the statement is true for n minus 1. Let a subset of xn be an ideal and also assume there is some non-zero G in the annihilator A x1 dot 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 xn A. Okay, so there is some G.
আপনি টেক্সট একটু দেখো। হ্যাঁ,
Fine.
ওকে ওকে, ঠিক আছে।
Okay, so inductive step, suppose this is 0. Suppose there is some G belongs to with least degree. Let's take least degree. Least degree. Least xn degree, not degree with least xn degree. Okay, if we consider a x1 dot dot xn to be a x1 dot 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 xn minus 1 xn, then by inductive then by case 1, then by the n equal to 1 case, we can say that there is some non-zero element that way there is some a not equal to 0, a belongs to a, such that a equal to 0. Such that a equal to 0. Okay, let f belongs to a inside a x1 x2 xn. Yes, write f x1 dot xn to be what, okay, b0 dot bn bm xnm bm not equal to 0 and b0 dot bm belongs to a x1 dot xn minus 1. Okay, so what is that? So a into f equal to 0 implies a into bi equal to 0, 0 lesser equal to or lesser equal to m. Let b denote the let b be the ideal. Ideal in a x1 x2 xn minus 1 generated by the by all generated by all coefficients COE I F F C I, coefficients of all elements of A. So if we consider such an ideal in a x1 x2 xn minus 1, then what we see that a there is an a b equal to 0 by a b equal to 0, that is fine, and 0 not equal to a belongs to a x1 dot xn minus 1. Now we can use induction. Now by induction hypothesis, there is some, let's say a tilde belongs to a star, such that what is that, such that a b equal to 0, there is a b equal to 0. Yes, there is some a belongs to such that a b equal to 0. If this happens, there is an a such that a b equal to 0. Now a, okay, no, so a tilde equal to 0. Now if there is some a belongs to a star such that a b equal to 0, then if you take any polynomial from a, then a multiplied by that polynomial equal to 0, because the ideal b is generated by all the coefficients of the polynomial, all the coefficients of all the polynomials from a. So take any polynomial from take any polynomial a from a and collect all the coefficients, then generate an ideal, then we generate an ideal in a x1 x2 xn minus 1. So if that ideal can be annihilated by a non-zero scalar, say a tilde, if we apply it, multiply a tilde by f, then it is 0, because the by obvious reason, I mean, there is nothing to prove. I mean, if we have taken all the coefficients of all the polynomials, generate the ideal in x1 x2 xn minus 1, and that is annihilated by some non-zero scalars, then what that does that mean? That means a tilde into all the elements of the ideal is multiplied is 0. So if we take any polynomial multiply by them, then it is 0. Then we are done. Then a tilde of f equal to 0 for all f belongs to a. That means a tilde a equal to 0, and we are done. This proves the McCoy's theorem. In particular, take a to be ideal generated by f. See, for the case n equal to 1, what we have proved for the case n equal to 1, it is enough. Okay, there it is. For the problem 2, this part, that f is zero divisor if there is in such a blah blah blah, that happens, the case n equal to 1 is enough for that part. We have essentially proved the same thing for n equal to 1 case. Okay, where is that? This. For n equal to 1 case, if we stop here, then we are done. But for the several variable case, we had to proceed till the last, and basically then we are done. And in particular case, if you take any f zero divisor, take the ideal generated by a and repeat the same argument, then you get some a such that this holds. Then fine. And okay, so as in problem 2-4, I am not able to do the problem 3-4, so I will post the solution, or I will do the solution whenever I have the solution. Till now the solution is not there actually. Problem 4, we'll do it later.
4 এরটা
Yes,
মানে 4 নম্বরেরটা?
yes, primitive.
ও
Okay,
প্রিমিটিভ পারিনি, 4 নম্বরেরটা করেছি।
where
And
okay, no, okay, no. So if anyone have some doubt on this McCoy's theorem and the proof of McCoy's theorem, please feel free to ask, then we will end the class. This is an important theorem, so we should do this.
ক্লাসের পরে একটু নোটটা একটু দিয়ে দিও, মানে এটা।
You are not taking the note? I mean,
হ্যাঁ নিয়েছি, লিখেছি।
sir will not provide the note, so please take the note. I can I will provide the note, but that does not mean you will not take the note. Okay, I will send the note anyway. So if someone has any problem or any doubt, please tell me. Otherwise, we will stop the class.
তো পরের দিন কি নেক্সট ডে থেকে কি 4 নাম্বার থেকে হবে তো, মানে প্রবলেম নাম্বার 4 থেকে হবে তো?
Yes.
হ্যাঁ ঠিক আছে।
हेलो रिपन।
Yes. Yes, Madhav.
हाँ एक्चुअली मैं अभी थोड़ा हम बात कर सकते हैं, मुझे थोड़ा कुछ डाउट है
Okay, just a
लाइक
minute.
एकेडमिक का ये
Okay, just a minute.
क्वेश्चन का रिलेटेड।
Okay, let me stop the recording first.